very much for your awesome insights on the standards for the space industry and how CubeSats and smallsats are taking us down some new ideas for big space to small space. So appreciate you taking the time for that. So I'm here to introduce our panelists here. For the audience, we're going to give you an opportunity to interact, ask questions of these guys. They are contributors, some of them to OMG, others are users of these space standards that you're going to hear about throughout the day. And so we'd like to thank them for taking the time to, one, all the time the contributors spend to playing in the OMG world. They don't do it, they're not paid for it typically. So we do appreciate them coming out. We're going to start with Justin Boss. He has over 15 years of experience in the satellite ground system industry. He has supported design, implementation, and support of many civilian, DoD, and commercial programs. He manages the Federal Solutions Group Research and Development at Real-Time Logic, or Kratos Real-Time Logic. Yeah, which one's the official one there? And he's an active, a long-time contributor to XTCE and now C2MS for the Space Domain Task Force.
Hi guys, I'm Justin. I'm a product manager, as Luis said, and just wanted to share that in terms of standards, at Kratos we have a product line called Quantum that I'm instrumentally involved with, and it provides for small satellite constellations a full end-to-end solution product line. Within that product line, we have Quantum Command, which is our C2 product that includes capabilities for telemetry and commanding, automation, grounded space links, as well as a user interface, web-based, of course. Within that, though, it's built on standards, and so it utilizes the XTCE standard. It also has GEMS for accessing and controlling the ground equipment. We also use other standards like REST and SNMP. And then we also have been working to build some C2MS or GIMSEC interoperability as well. And so across the board, that is a product that has a lot of the standards here at OMG within one, I'll say, solution set. And we've recently actually had an on-orbit demonstration with it called Scout, and we have a video of that out in outside the room.
Okay. Next up will be Afshin Khan. She's a systems engineer for the GOES-R Series Missions Operations Support Team at NOAA. Holds a BS in computer science, a BA in English, a MS in computer science, and has used all those throughout her career to various degrees for the series of database tasks related to GOES-R. She's also got a very nice presentation on doors, and there's a link to that on our website. She's got some slides that she's going to go through. Yeah, you bet.
Hi everyone. I'm going to talk to you guys about the GOES-R experience with using XTCE to manage and disseminate our TNC databases. Is everybody here, at least at a rudimentary level, familiar with XTCE? I'm getting lots of nods, so that's good. If you're not, it's basically a format to describe telemetry and command content for missions, for different missions. Press next. Yeah, can I just use this? So first I'll just give you an overview of the GOES-R mission. I'll describe the challenging initial conditions that we faced related to the database task. I'll talk about the customizations and resolutions that we needed to be able to use XTCE on GOES-R. And then I'll just touch on how important communication was throughout the whole process. So GOES-R, it stands for the Geostationary Operational Environmental Satellite Series. This is actually a follow-on to a whole series of satellites that NOAA has maintained. Basically, the first GOES satellite launched in 1975, and I was talking to Dan Smith earlier today, and he told me that he worked on several of the GOES satellites. The GOES-R mission was a follow-on to the GOES-NOP mission, and it was supposed to be the next generation of satellites. It had multiple advantages over the GOES NOP series. We had 6 instruments. They were both Earth and Sun pointing instruments, as well as the capability to monitor space weather and solar conditions. We launched GOES-R in November of 2016. We launched GOES-S in March of just last year, so basically 2018. And there are plans for 2 more satellites for this series. So initially, what was going on? We had basically all these stakeholders, and they were distributed across the nation. And they had, we had not mentioned XTCE explicitly in our requirements, so basically nobody knew that we were supposed to be using XTCE as the database exchange mechanism. And when we first mentioned this, people would be confused even, if we mentioned it in a telecom, people wouldn't even know how to spell it. They were not even familiar with XML. And everyone had most of the instruments were pretty far along in their development. They all had their own telemetry processing and commanding capabilities, which were unique to them. And they all already had their own miniature proprietary ground systems. So they basically had a box to communicate with their specific instrument. The spacecraft vendor was just getting started with their contract, so they weren't quite as far along. So here, this is just showing, the different formats that the databases were originally in. We had a lot of auto-generated XML. It didn't really conform to a schema per se. It was auto-generated by the flight software code. We had two databases in Excel. One was just in an Oracle database. But we knew at the time that OS Comet had been selected as the ground system for satellite operations, and In Control was selected as the INT ground, the ground system to be used during the integration and testing phase. And the spacecraft vendor was supposed to be the integrator for the GOES-R satellite command and telemetry databases. So both of these, both In Control and OS Comet, they used XTCE as an input. But none of the instruments or the spacecraft were using XTCE as their, yeah, it did. I was just moving the,
Just touching the mouse, huh?
yeah, I was trying to point it. Thank you. It's correct here.
There's a little laser on that.
Yeah. These are on there.
So we knew that XTCE would be the mechanism to transport databases between these two entities, and an XTCE formatted database would be the input to OS Comet, which was going to be our ground system. So how did we do it? We began the conversion in 2010. And we launched the first satellite in 2016. There was a lot of work that went in between 2010 and 2016. We already knew that the format had to be XTCE, but we began meeting with all the different stakeholders to discuss the XTCE format, to provide them with documentation. We gave them the XTC schema and the green and blue books from the CCSDS group. Also, we gave them a converter guide that was provided to us by OS Comet, which basically outlined what fields were supported by OS Comet. Because we knew we didn't want to have elements and attributes in the database that weren't supported by OS Comet. The spacecraft also created an ICDE based on a list of XTC's tags that were supported by OS Comet. And initially, the spacecraft vendor actually suggested an intermediate format to XTCE. They proposed that the instruments provided in this flat file format, and then the spacecraft would then convert it into XTCE. So we actually decided not to take this suggestion, and that was the best road not taken, because that would have, XTCE was already a predefined standardized exchange mechanism, and implementing this suggestion would have introduced extraneous intermediate layers, and we would have had additional complexity that was not needed to an already convoluted task. So throughout this process between 2010 and 2016, we had to investigate a number of database issues. If we had to go through this intermediate format every time, that would have just added more complexity and more time needed to resolve those issues. So then in 2012, the database maturation was in progress for all vendors. They were finalizing their flight software. We held more meetings with them, and these are also described, the resolutions and workarounds are described in a later slide. Then in 2013, we had the first satellite database, which was delivered in the XTCE format. We conducted end-to-end tests using our XTCE database. We investigated any issues that were encountered. Then we launched GOES-R. Since we continued working on the databases even after launch, because there's always updates that are needed, especially if there's a flight software patch that's needed. We launched GOES-S last year, and this year we're continuing to work on GOES-R, S, and T databases. So how did we fit the database into the XTCE format? Initially, so this is not to scale really. Initially, many of the items which needed to be in the database, they were already, you could just fit directly into the XTCE that was supported by OSCOMET. Then there are a few additional items that were supported by the XTCE standard, but not supported by COMET that we requested, and they added it to COMET. There were some items that just could not fit into the XTCE format. So we just developed customized handling for those cases. So like I said before, more than 90% of the telemetry and command content fit directly into XTCE fields. File loads required special processing, so did table dumps, file dumps, memory dumps, any type of dwell telemetry required specialized handling. We used the abstract attribute to identify which commands in telemetry require special processing. Of course, telemetry often requires calibration to be applied by the ground system. And so there's a polynomial calibrator which was already part of the XTCE standard. We couldn't use that for all calibrations. There were some that needed advanced math functions. So what we were able to do was just use the C language, the C programming language, along with or CCL. In some cases we use CCL, in some cases we use C. We use that for conversions that were required beyond polynomial calibrations. And just as an aside, we also, if something was written in CCL, it was also provided as JAS, which is in controls language. For byte order, we found that only bit order was a field that was supported by the XTCE standard, but we needed to use both little and big endian formats. So we used the ancillary data tag to specify byte order. This tag also came in very handy to customize the vendor databases. And for some of them, we needed to have traceability to their original database, because like I said, none of the native databases were in the XTCE format. So to be able to support testing on their side, in many cases they needed to have traceability to the XTCE output. And this ancillary data tag provided us with that possibility, because we couldn't embed anything in there that was not XTCE compliant. It was like a common field for us. Another feature of XTCE that really helped us was the space system hierarchy. So basically what we were able to do was just use the GOES-R name as the parent space system, and we placed all the other the instruments and the spacecraft as separate space systems within the parent space system. All of these entities had different development timelines, so we had different asynchronous deliveries of the flight software, and most of the times there was a flight software update, there was an associated database update. So we were able to basically plug and play different deliveries and without affecting the other portions of the database. And this really helped us meet our mission milestones, and the deadlines that we had on the GOES-R system. We also had a dedicated meeting for database changes. This was called the database CCB. So even though both OSCOMET and Control were using XTCE, they still had constraints and dependencies which were not documented and which are not going to be documented as part of the XTCE schema. So for an example, an instrument was using sequence containers with duplicated restriction criteria, and we removed that. Then one ground system could no longer process the XTCE database. It must have been the wrapper that broke, but because I just heard that Control is not using the XTCE database as an input. But still, we found out that we still needed to communicate about changes that we made. So, I would say that goes our mission, owes part of the success to the XTCE standard. We had thousands of telemetry points, we had thousands of commands, and 2 different ground systems, 6 vendors, but we managed to launch 2 satellites successfully, and I can say that we don't have major outstanding database issues at this time. And I think part of the success is due to this XTCE standard. Thank you.
So it's super exciting for us to have an end user like Afshin here with us today. We're standards nerds. We get caught up in developing them kind of internally, and we forget sometimes that we have to empathize with the end user. And so it's really nice to have her here, providing us feedback and giving successes, and hopefully after the fact telling us where we can make it better for her. Next, I'd like to introduce Andre, who sounds like he got off on the in-control problem with Gozar, that maybe they're not using XTCE on that program. But he
left the frying pan.
Yeah, exactly. But he's been a member of OMG for how many years now? 2, yeah. And has provided us with a great insight on XTCE specifically, works really well with Dave. He's from L3 Technologies. It's been 20 years designing and implementing ground systems for aircraft flight test telemetry and satellite command and control.
Hi, my name's Andre. I work at L3 Technologies, as you said. I primarily work on aircraft flight test, and I'm one of our resident experts on the equivalent to the space specs in that field called the IRIG standard. So when we got our first job to do an XTCE translator or database creator, I was tasked with that. And so I was basically thrown into the deep end. And at that point, I was handed a XML schema and said, "You've got 40 hours, good luck." And so more than 40 hours later, I had plotted my way through it, and I found there was not a lot of community support out there on the internet at that time, which was one of the big lessons learned, was that is something that could really help with space specs in general, is create some kind of community where people can get together and ask each other questions. My second program, on the other hand, I was given a simple requirement, which was in control shall implement an XTCE translator. And I was told that the customer would be somebody who was somewhat involved with this group here, named Dave Overeem, sitting on the end there. And he would be my point of contact when developing this new version of our XTCE translator. And so that was scary, and it turned out to be one of the greatest things that I had, was now I actually had somebody I could go to with questions. I realized I had made a lot of assumptions that were wrong, and it turns out that a very iterative process. Dave and I worked hand in hand to make what I think is a pretty good implementation of the XTCE standard. And so we have now made that into our generic product. And recently I'm actually seeing people that are coming in and asking us, so what do you do with XTCE? And they're being able to use it right off the shelf. And I'm seeing a lot of the same questions. How do you handle CCSDS transfer frames? Or how do you handle dump telemetry? Or, things like that. And so, again, this is coming back to that community idea of maybe creating some kind of forum where people can get involved. But one thing that I've also heard, which is common among the people who are just getting involved, is they found this set of tools online that they say are pretty awesome. And so with that, I will let Dave demonstrate what are his XTCE tools, and they're pretty great.
Yeah.
Thanks.
So this is Dave. Before we get started with Dave's demo, I'd like to point out to the audience, we have some flashcards. There's pens in the back. With the panel today, what we'd like you to do is, if you have any questions, to go ahead and fill out the flashcards with your questions, and then we'll take them up here and ask them as we have time. So while he's doing his demo, if you're thinking of things that you'd like to us to chat about, go ahead and fill the cards out. Dave is a systems and software engineer at Boeing. Are we allowed to say that? I just did. He's been there for 18 years, specializing in satellite command control integration, operations, and automation for several programs and platforms, both manned and unmanned. He's also the sponsor of some XTCE open source COTS supports packages, which he's going to give you a demo of today. All right. And if you give us a minute, patience, we're going to swap some cables here quickly. Can we pass it to me? That's way.
So thanks for the wonderful introduction, Louise. And fortunately for everybody in the room, I had oral surgery last Monday, so I'm speaking a lot slower than I usually do. And unfortunately for me, fortunately for you. So I've been involved with the OMG since probably around 2002, and I've always been fascinated with the XTCE standard. I don't know why, it just sort of clicked with me. It's one of these monstrous standards that was developed by committee, this particular committee. And I got a chance to use it in a very serious way about 7 years ago on the Iridium Next constellation, which is, they've just got done doing their 8 launches of 75 satellites. And I've also used it now on 3 other programs. So when we first sort of delved into it, it was chosen at the time that Andre from L3 would be the implementer of that on the command and control COTS side. And quickly we discovered that we sort of dictated that XTCE would be used because we wanted to use standards, and that XTCE was this sort of monstrous community-built standard that had an awful lot more ramp-up time than we initially anticipated, and especially because I was working with the Europeans, and they have an extension to the CCSDS called the European Cooperation on Space Standards, or ECSS. And they define a packet utilization standard, which rides on top of the CCSDS, which is significantly more complex than even CCSDS is, if that is possible, and I promise you it is. So in that sort of development process, one of the things that we lamented was there's no community support for XTCE. You would get this monstrous schema from the OMG, and it's not immediately obvious or easy on how to implement it. So I sort of jumped into this idea that, well, we needed to have community support, and started doing it myself. Oh, does that help everybody? So I came up with a library and a user interface tool. The user interface tool that we're sort of going to show you here is just a thin wrapper on top of what is the library itself. And we have some built-in examples into the tool, which helps to get folks ramped up, and we've actually got some participation from the community now. Of people who have joined the project and been utilizing this. As Andre has said, he's now getting questions from customers. It's like, okay, well, I downloaded this tool and it works there. Why doesn't it work here? So we support in the library and in the user interface itself the full structure of the space systems, sort of as Afshin alluded to, that many of the different components work well by being in their own space system, because that way you can have a disparate delivery life cycle. And we also support, within this tool and the library, the X-include facility, so those documents can all actually stand alone. And the vendors can deliver their document and not worry about the rest of the database. So in this little example, which is built into the tool, if you download it, you get the examples along with it. Defines a number of these sort of notional kinds of space systems. It's not a very big demonstration database because it's actually part of a unit test suite for the tool.